Here's a little review before we talk about linear relations again today. So it says Eric earns $185 in 20 hours. If he earns $157.25, how many hours does he work? There are multiple ways that you can try this problem. Multiple different solutions will all get you the exact same answer. My preference is, because we're talking about two things, money and hours, and then I'm giving you money and asking about hours, to set this up in a tic-tac-toe board. So that's my preference. So here's the tic-tac-toe board. Like I said, money and hours. $185 will have to sit beside the dollar sign. And the 20 hours will have to sit beside the H, or if you prefer writing the whole word hours, you can do that. Then this number, 157.25, has to fit in one of the two remaining boxes. And for this particular question, we should fit it here, because $157.25 is a dollar figure, not an hours. So we get to put that here, and the remaining box is filled with an X. So now, if you want to, you can zigzag your way through this, but some people are going to want to take 185 and put it on top of 20 outside the chart, equals 157.25 over X outside the chart. And again, we can zigzag. Start at the letter, go to the next number, zigzag, and then end up at the 185. And the symbols that fit in here, equals, multiply, divide. So if I take out my calculator and I get an answer for that, that should be a number of hours. So 20 times 157.25 divided by 185 gives me a nice, perfect whole number answer of 17. So now I can write a therefore statement that says he will work, he does work, he works, he will work 17 hours. And why do we know it's hours? Because this 17 fits in here for the X, which is beside the H. All right, so now let's talk about some more money. So this is a very common place that you'll see in linear relations, is talking about money. So the next sheet is printable off the Google Classroom. It's actually two sheets, so back front. There's this question, which everything is all written in words. This note will take care of 3 of them. The other 3 are your responsibility. Then the other side is this, which is charts. Again, this note will take care of 3 of them. Your responsibility is the other 3. So let's start with the words. So the question says, write the equation for each relationship in the space provided. Show any calculations you made, so we can keep that. Indicate whether the line modeling the relationship is solid or dashed. So what I'm going to do is I'm actually going to take a dashed line. No, let's make it solid. And strike that out. So what we're going to do instead is we're going to talk about whether or not the relationship is a relationship that shows partial variation or direct variation. And if you've forgotten what that is, we'll recap that in a minute. While I've got my line maker out, the instructions on this page are the same, and I'm going to wipe out that instruction as well. So back to the original. So for each of these questions, you need to know that there is going to be some sort of base price, so a price that you start with, a starting point, and then something's going to change, and that is your rate of change. Your rate is always a rate, meaning that it's always going to be something like a per, so it could be similar, or you could actually see the word per. So we'll take a look at the question. So I'm going to pick some letters that actually make some sense, and hopefully you pick up the pattern by the time we're done this. So it says a family meal deal at Chicken Deluxe costs $26 plus $1.50 for every extra piece of chicken added to the bucket. So some people are going to want just the basic meal, and then some people are going to have some extra chicken, so they're going to have to pay a little bit extra. So what we're doing is we're figuring out how much the meal is going to cost. So I'm going to dig out a C for cost. And I hope that you understand by reading this that the family meal deal at Chicken Deluxe costs $26 means that $26 is the least amount that you are going to pay for this bucket of chicken. And then if you decide to get extra chicken, you are going to have to pay an extra $1.50. We're going to add on $1.50, but it's $1.50 for every extra piece. So if it's 2 pieces, I have to double that. If it's 3 extra pieces, I have to triple it. So this is your rate of change. And if you take a look at the language in here, it says plus $1.50 for every extra piece of chicken. That means $1.50 per piece of chicken. And that's why it's the rate of change. And your rate of change always gets the letter. So the structure you'll have is, you'll have a letter, so I'm going to use C, equals, you'll have your starting point, then you'll add on the rate of change, and then you'll have another letter. I'm going to wrap it in a bracket so it stands out for you. Now the only trick to this is that somebody might do this, and this is or. So you don't have to list both of them, you have to list what comes to your mind first. So you might have this written with the $1.50p first, and then add the 26 after. So both of these are the same thing because the $1.50 always gets the letter and the 26 does not. Now there's one other thing that you have to do with this, and that is you have to tell your readers, that'd be me or Mr. Chalice or whoever else is reading your work, what the letters stand for. So P is number of pieces of chicken, and C was the cost, and the cost was in dollars. So now I'm going to go over to here. So I'm going to do a little zigzag of the questions. So this question says, the country club charges $270 for their facilities plus $29 per guest. So that means that if you're going to have a wedding, for instance, you are going to be stuck paying $270 even if you invite no one. So that means my cost at its very least will be $270. But then I want to invite people, and every single person I invite is going to cost me $29. And you can put an N here for number of guests. You could put a G here for guests. But notice how this says per. That's your rate of change. So if I go back up to my little blurb, it's C equals, or whatever letter you choose, equals the starting point, $270, plus the $29 per guest. There's your rate of change. And you can use whatever letters you want, as long as you tell your reader what it is. So C is cost in dollars, and N is number of guests. And don't forget your or. Somebody might mess with you a little bit and want to reverse this. So they might start with the 29N plus the 270. So this per is the rate of change. This 270 is the starting point. With this one, here was the starting point. This was your per, so that was the rate of change. So let's see about this last one, the race car. Let's not do a zigzag. A race car travels at a constant speed of 220 kilometers per hour. That's a per. That's a rate of change. Write an equation for the total distance traveled over time. So instead of C, I'm going to use D for distance, equals, and if I check this out, I don't see any starting point. That means, and if you think about it, it's true, that means our starting point is 0. And it's 0 because if you're traveling 200 kilometers per hour and you're not actually starting the time, that means you're going nowhere. And then we can add on the rate of change, and I'm going to put K for kilometers. What we'd prefer you do is when your starting point is 0, that you not write it down. And that's your or. Both of these are just as good as one another. And a little aside, starting point equals 0. Now, what did I forget? I forgot to tell you what these things are. So D I'm going to use an H for hours, not K for hours. D is the number of kilometers, and H is the number of hours. So somebody else might have written this, T for time, and they'd have to say that D is the number of kilometers and T is the number of hours. There's also me, where my initials are M, then T. I can make this personal. Not logical. So you can pick whatever letters you like. What I like to do is pick letters that actually make sense, which is why K wasn't a great letter, because it looked like it was for kilometers when it was supposed to be for hours. So I like to pick letters that actually indicate at least the first letter of the word. So that's what you do if you have a statement. So you've got 3 others. The answers are online if you want to check them out. The nice thing about the ones that we have left is they're 2-number questions, so there's no tricks about 0. But before we leave this, I just want to remind you that this is an example of partial variation. And the reason that it's an example of partial variation is that the starting point is not equal to 0. That's the definition for partial variation. It means that this is another example of partial variation. Remember that you may see it called indirect or partial variation, and the reason is because our starting point was not 0. And then the last question, oh my gosh, there is a starting point of 0. So this is direct variation, and the definition of direct variation is that the starting point is equal to 0, and it is. So now let's go on to the charts. We're still going to have to do the same thing, as in we're still going to have to indicate what our letters are, so I'm going to write that stuff off to the side. Our goal is still the same. Write the equation for each relationship in the space provided. Show any calculations you made. So, what I'm going to do first of all is point out the starting point, if I can. So the starting point for this question is $9.40. And that's because it's across from the 0. Meaning that if I have a plain old basic pizza with 0 extra toppings, that's the least amount it's going to cost me. So this is another cost question. So I'm going to say C equals, and I know it's going to start with $9.40. And then I'm going to have to add an amount on. But with this, without the words, you have to do calculations. So you have to find rate of change. So I'm going to do that here. Remember that rate of change requires 2 calculations. One on this side to find out what this number is, and one on this side to figure out what this number is. So I'm going to take $7.80 in the bottom there and subtract off the $15.70, and I get 2.1, which is $2.10. Then I'm going to do it again. $15.70 minus $13.60, 2.1, so $2.10. Do it again. $13.60 minus $11.50, same thing. So far we're doing well. This one has to work or it doesn't count. Whew, it does. So the rate of change for this question, remember it's right over left, so that's $2.10 divided by 1, which is $2.10. And that is the per, it's $2.10 per topping. So I'm going to do that, picking logical letters. Remember there's an or. It doesn't matter which one you put first and which one you put second. You will need to know one of them, and that is to put the $2.10 T at the beginning. See the $2.10? The rate of change always gets the letter because it's changing, and this doesn't, and it sits alone, no letter. So I need to tell you what I was talking about. So C is cost in dollars, and T, number of toppings. All right, let's look at this one. Let's see if I can zigzag this time. So, oh my gosh, I don't have a starting spot. Yeesh. So I better figure something out. 400 minus 300, 300 minus 200, 200 minus 100, 100 minus 0. 330. Oh, ignoring that telemarketer, is 40. 290 minus 250 is 40. 250 minus 210 is 40. So my rate of change is equal to 40 divided by 100, right over left. And 40 divided by 100 is this decimal, with or without this 0. That means that every single kilometer is going to cost us 40 cents. We need to figure out this. So I should, oh my gosh, they are ruthless. I need to figure out what number plus 40 is 210. And that puts 170 in here, and that is my starting point. So let's make a purple equation like up here. C is equal to 170 starting plus 40 cents every kilometer. Yep, that'll do. And my reversal is this, and my communication. So a lot of cost questions. Let's do one more. So that leaves you with one that's complete, one that's a little incomplete. Let's do an actual zigzag. I think they're calling me again. Holy smokes, I'm popular. Starting point equals 0. I'm going to pause and tell them to go away. Okay, they're gone. So, it's way easier when we give you the starting point. Remember, your starting point is always across from the 0. Now I know how my equation works. So cost of attending a hockey tournament will start at 0, and then we're going to add on some rate of change amount, and we'll have it based on the number of athletes. So this is a number we have to calculate. Start here. 1, 1, 1, 1. So that's easy enough. That's easy enough. 900 minus 675. 225. 675 minus 450. 225. 450 minus 225. 225. And 225 minus 0, I can do that in my head. So we have 225 divided by 1, which is 225, and that sits beside the n, because the rate of change always gets the letter. So how am I deciding these letters? Well, this is cost, so the cost is calculated by doing all this work with an n. So if you don't feel like doing this, you can put a C for cost up here, and you can say, oh, I want another letter, and I'm going to use a K. In the first example, it was cost and the number of toppings. I picked a T. So if you've got the chart, it's really easy to communicate. What I do want to remind you of is that you don't really need to write down zeros. You can leave them off. So the last thing we have to do is we have to backtrack through all of this to find out whether it's partial or direct variation. And this is an example of partial variation, or indirect. Because we have a starting point that is not 0. It's $9.40. With this one, this is an example of partial, or if you prefer, indirect variation. The reason is always the same. The starting point is not 0. And with this question, we have a starting point of 0. That means we have direct variation. By the way, I was not rude to the telemarketer. Okay, so the big picture about this, you have 3 more to take care of here. So number 2, number 3, and number 5 in the word description. And you have number 2, number 3, and number 6 in the chart description. The big picture is that linear relations can be represented in a number of ways. We can give you a table of values. We can give you a graph. This one didn't have graphs. You've dealt with graphs before. We can give you an equation, or we can ask you to make an equation. We can give you a description. Right here, there's descriptions. And we can also give you pictures, like in the pattern questions that end up as linear relations. So there's a number of ways that you can actually be given or asked for a linear relation. So that is the end of this. I'm going to show you the other worksheet that you can work on either now if you finish those 6 questions, or if you have time a little bit later. So there's 1, 2, 3, 4, 5 word descriptions. Oh, there's a 6th. And then there's a couple of multiple choice questions here. Number 7, number 8. And that's it. So it says there's 3 pages, but there's a glitch in this printing of the PDF. So there's no 3rd page. So it's actually only a 2-page document. So that is your job right now. See ya.